Hello and welcome. Adam here from the XMPro team. In this introduction to XMPro's AI agents, I'll show you how our platform can transform your industrial operations with different types of intelligent agents working together. When we work with our customers, we often discuss the decision intelligence journey that organizations are on. This journey moves from basic dashboards and monitoring all the way to autonomous operations. At the beginning, you have traditional dashboards that simply inform human decisions. As you progress, AI assistants and co-pilots start augmenting your team's decision-making, essentially creating super engineers with AI support. And at the most advanced stage, you have autonomous multi-agent generative systems, or MAGs, that can execute processes independently with proper oversight. What makes XMPro unique is that we support this entire journey on a single platform, so you don't need to switch tools as your capabilities mature. Let's look at why leading organizations are investing in this approach. The challenges we hear consistently from our customers fall into three categories: growing operational complexity, widening skills gaps, and increasing pressure to do more with less. Your operators who once managed 3 or 4 screens now face 20 to 30, making systems significantly harder to monitor and control. It's not just about retirements. Keeping your existing teams up to date is challenging, and finding skilled industrial workers is increasingly difficult. Meanwhile, budgets are tighter everywhere, creating pressure to improve efficiency with fewer resources. So this isn't about replacing people, it's about augmenting your teams to handle increasing complexity when skilled resources are scarce and cognitive demands are overwhelming. Now, let's explore the different types of agents XMPro offers to address these challenges. First, we have content generation agents that can take your technical documents, engineering data, or control specifications and create structured reports or new specifications. These agents don't make decisions, they simply organize information efficiently for your team. Next, we have AI assistants, conversational interfaces where your team can ask questions and get guided through answers and actions using real-time operational data. Finally, we have cognitive or decision agents that enable autonomous operations. Unlike simple automations, these agents reflect, reason, and decide, similar to how human experts approach complex problems. XMPro uniquely brings all three capabilities together in one platform. Before we dive into the demonstration, it's important to understand how these agent types complement each other in your operations. Expert agents leverage your documented knowledge base, manuals, procedures, and technical specifications to answer general questions about equipment or processes. AI assistants connect to your real-time data to tell you the current status of machines or identify problematic assets. AI advisors go further by proactively analyzing your data, surfacing recommendations, and explaining situations without being prompted. And MAGS teams take this to the highest level. When recommendations are consistently valuable, these agent teams can take action within carefully defined boundaries that you control. The key advantage is that all these capabilities run on the same underlying platform. We simply configure it differently based on your specific needs and readiness. Let's see these agents in action. I've loaded our smart factory environment in XMPro Designer. This simulates a complete facility with various operational areas: a solar farm, water treatment plant, power station, cold storage, and more. For this demonstration, let's focus on the power station. Here's an AI assistant in action. You can see some example questions, or you can start a new conversation. I'll ask, what is the current status of all my pumps? What happens next demonstrates the power of our system. The assistant first checks your available documentation, then determines which data stream to query. In this case, the pump condition monitoring stream. It connects to the live data, retrieves the latest readings, and uses an LLM to generate a conversational answer. In just seconds, it tells us both pumps are operating normally, saving your operators from having to check multiple systems or screens. Now let's look at an expert agent example. When I ask, explain how this type of transformer operates, it draws on your internal documentation to provide a comprehensive answer. You can also request source citations, ensuring traceability to specific manuals or knowledge bases. This is particularly valuable when training new staff or troubleshooting complex equipment. Returning to the power station view, when I click on a specific transformer, it automatically triggers an AI advisor. Notice it has already analyzed the transformer's data and flagged a low power factor issue. If I ask, why is the power factor a problem? The advisor immediately explains what this means, the potential risks, and recommended actions, all without requiring your staff to interpret complex readings across multiple systems. This capability to instantly contextualize operational issues represents a significant advancement in how your teams can monitor and respond to conditions. Taking it a step further, let's look at a MAGS team focused on predictive maintenance for the power station. This team operates with a clear objective function: reduce failure rates, minimize thermal stress, improve uptime, and speed up reconnection after faults. 3 specialized agents work together: load management, health, and environment optimization, each following a continuous cycle of observing, reflecting, planning, and acting. You can see new observations and reflections happening in real time, with all actions governed by the rules and parameters you define in the team profile. As you watch, you'll notice bubbles appearing on screen. These represent the agents actively making observations and reflections about your operations in real time. This visualization gives you insight into the ongoing cognitive processes. Each agent is continuously monitoring different aspects of your power station, sharing insights with other team members, and collectively working toward your defined objectives. Let me briefly show you how these teams are configured. In the team administration area, you can see the objective function, compliance requirements, and agent instances that make up the team. For each agent, you can define which tools they have access to and what profile they're based on. The profile is essentially the model or template for the agent, allowing you to create multiple instances for different equipment while maintaining consistent base capabilities. What's powerful about this approach is the separation between profiles and instances. Your IT team, or Center of Excellence, maintains the profiles with governance controls, while your operations teams can create instances and teams as needed. This ensures that individual agents can't override critical safety rules or organizational policies. The agents operate within strict governance frameworks. They can't go beyond their defined parameters. Their actions are constrained by operational rules and deontic principles that you establish. These are essentially rules of engagement that ensure agents can never take actions outside acceptable operational boundaries. The agents run on XMPro's industrial-grade infrastructure, using standard protocols like MQTT, OPC, and other industrial communication standards. We maintain a critical separation between intentions and actions. An agent might plan 10 potential actions, but those only execute if they're approved and connected to actual actuation systems in your environment. This separation ensures industrial-grade safety and governance throughout your operations. From a technical perspective, all this agent intelligence is running on top of our existing data stream infrastructure. If we look behind the scenes, you'll see that a MAGS team is essentially powered by an XMPro agent that processes all the observe, reflect, plan, act logic. This architecture makes the system incredibly scalable and reliable for industrial environments. One important aspect is how we integrate with your existing systems. Agents receive data through standard XMPro data streams, the same ones you'd use for dashboards or condition monitoring. Before the data reaches the agents, we apply grounding, running it through appropriate analytical models, engineering libraries, or expert systems. This ensures that technical calculations or predictions aren't left to the LLM, but are handled by proven, specialized tools. The agent then interprets these results to make more informed decisions. Once agents develop plans or intentions, they don't directly control your systems. Instead, their recommendations flow back through data streams where you define exactly what actions can be taken and under what conditions. You can also have these recommendations sent to Teams or Slack for human approval before execution, maintaining appropriate oversight. And speaking of communication, you can interact directly with individual agents or entire teams. You can send them observations like, "We're planning a shutdown next Friday," or ask questions about their current focus areas. This creates a collaborative environment where your teams and AI agents work together, with the agents adapting to your operational context. Centralized management is key to maintaining control. All agent profiles, skills, operational rules, and memories are managed in one place. We maintain a centralized prompt library where all observation, reflection, planning, and action prompts are managed and versioned. All of this creates a scalable, governed, and explainable system that you can trust in your critical operations.